Hey guys, this is JB Mon from Planting Seeds Tutoring. In today's video, we'll be looking over polar coordinate system and how we can convert coordinates from the polar to the Cartesian coordinate system and vice versa. Don't forget to use my referral code JBMon20 to get 10% off on your next tutoring package. Let's start off by comparing the polar and the Cartesian coordinate system. So far, we've only dealt with the Cartesian general system, which is also known as the rectangular coordinate system. And we can compare that with the polar coordinate system. So in the Cartesian system, we generally have our coordinates written as either x comma y, which is a two-dimensional plane where x represents horizontal movement and y represents the vertical movement. Or we can also write it down as x comma y comma z, where x and y represent the same, and z represents the movement through in and out of the plane itself, in and out of the surface itself. And this is going to be 3D, while this is going to be two-dimensional. So whereas in polar coordinates, the coordinates are actually written as r comma theta, where r actually represents the radius, which in general just represents the distance from the origin of a point, from the origin to the point itself. So this is the radius, and theta actually represents the angle from the horizontal at which the point is found, the coordinate is found. Angle from horizontal. Now, another thing that you want to recognize about the Cartesian system, or about the polar coordinate system, is the fact that there are an infinite number of ways almost to represent there are an infinite number of ways to represent any coordinate in the polar coordinate system, while that is not true for the Cartesian system. So there's actually an infinite number of ways to represent a coordinate. For example, the coordinate 2 comma pi over 6. This is the same. This can be rewritten as just -2 comma 7 pi over 6, which is the same thing as writing down -2 comma -5 pi over 6, which is also the same thing as just rewriting it as 2 comma 13 pi over 6. And this is just because the angle, you can always just add 2 pi to it, and you would still be able to get the same coordinate. When a negative radius just means it's going in the opposite direction. So in general, all of our radii go in this direction, or towards the angle, just one counterclockwise direction towards the point. Whereas that's not, whereas it would be clockwise if it's a negative. So something that's very important to recognize in the polar coordinate system is to really know the unit circle. So the unit circle we have at 0 degrees, all of our x and y coordinates are going to be, the x coordinate just represents sine theta, or not sine theta. The x coordinate represents cosine theta, and the y coordinate just represents sine theta. So sine of 0 degrees or 0 pi, that's equal to 0, whereas the cosine of 0 degrees or 0 pi is equal to 1. The cosine and sine of 45 degrees or pi over 4 is equal to root 2 over 2 comma root 2. All right. So to convert from polar to rectangular coordinates, so polar to rectangular or Cartesian, all we really need to use is a fact that says that x, the x coordinate on the Cartesian plane, is just equal to r cosine theta. In the unit circle, r is equal to just 1. This is a circle with a radius of 1. Hence, the x coordinate is actually just going to be at 1, 0. I mean, the x coordinate is just going to be 1. 1 times cosine of 0, which is 1. The y coordinate is just going to be represented by r sine theta. So for example, if we have a problem which says to convert the polar coordinates to convert these polar coordinates, let's say 2, so let's go with 3, pi over 2. To convert the coordinate 3, pi over 3 to Cartesian, we can just use this formula. I mean, these two formulas right here, and get that the x value. I mean, 3, pi over 3 is the same thing as just writing down 3, 60 degrees as well. I'll also write it down. But the x coordinate would just be x is equal to 3 times cosine of pi over 3, which is just equal to 3 times cosine of pi over 3. That's just equal to 1/2. So the x value is going to be a 1/2. Now the y value would just be it's just going to be r sine theta. So the r value is 3. Theta is pi over 3. So it's going to be 3 sine pi over 2, which just becomes 3 times the sine of pi over 3 is root 3 over 2. Root 3 over 2. So we get that our y value would just be 3 root 3 over 2. So 3, pi over 3 in polar is the same thing as 3 halves, 3 root 3 over 2 in Cartesian or rectangular. Now, how can we convert from Cartesian to, or the rectangular coordinates back to like a polar coordinates? Well, to convert to polar coordinates, we just need to use, so it's just pretty much you can think of these as separate right triangles. So you can technically just use right triangle formulas, SOHCAHTOA, which gets us that the angle theta is equal to tan -1 of y over x, and we get that r is equal to, using Pythagorean theorem, the square root of x squared plus y squared. All right, so in our case, we have x is equal to 1/2. So x equals 1/2, and y is equal to 3 root 3 over 2. 3 root 3 over 2. So r would just equal 1/2 squared plus, or actually not 1/2, it's just 3 halves. 3 halves squared plus 3 root 3 over 2. Right, x is equal to 3 halves squared, which comes out to being 9 over 4 plus 9 times 3 over 4, which gets you that an r value which is just equal to 9 over 4, square root of 9 over 4, plus 27 over 4. 27 plus 9 is 36, so r is equal to square root of 9, which is equal to 3. Now, to find the theta is just equal to tangent, the inverse tangent, or the arctangent of y over x, which is 3 root 3 over 2, divided by 3 over 2. The 2's cancel, 3's cancel, and now you're left with theta is equal to tangent, the inverse tangent of root 3. Well, the inverse tangent of root 3 means that the tangent of theta, this means that the tangent of theta is equal to root 3. And this is only true at pi over 3. That's where sine divided by cosine gets you root 3. All right. Thank you all for watching. I hope you have learned something new. See you guys in the next video.